This tutorial will describe the steps to create a family of equal parts that move in the same trajectory but with a delay from each other. First, start by setting the required units for the simulation. Next, create a bulk material and rename it to Apple. Next, define the material properties and interactions. After the bulk material properties have been defined, the particle shape need to be created. Add a particle shape from the library. Choose Import Custom Particle Shape and select the CAD geometry provided with this tutorial. Choose the units and leave the rest of the import parameters setting as defaults. Next, set the size distribution of the bulk material. For this simulation, we'll select random and set the minimum and maximum values. You must calculate the particle properties for the new particle shape. Create an equipment material with the following parameters. The next step is to import all geometries and add kinematics for the slatted conveyor. Import the CAD file provided and set the units to millimeters. Leave the other parameters as default. We will create one slat geometry and assign the appropriate motion. This comprises of two linear velocity motions, to move the slat forwards and backwards along the conveyor. Then two rotations to rotate the slat around the end of the conveyor. First, add a polygon and rename it Slat. Input the dimensions and position values. Create a translation kinematic and name it Forward. Set the movement settings and ensure reference space is global. Also, ensure Move with Body option is not selected. Select Display Vector to check the motion direction is correct. Next, create a linear rotation kinematic called Around Front. Set the kinematic parameters. Currently, we have different units for the rotation kinematics. Change it to degrees per second as per this tutorial documentation. And ensure the reference space is global and the Moves with Body option is not selected. Next, we'll copy the forward kinematic previously created with a time delay of 4.31 seconds. Rename the new motion to backward and set the initial velocity to -0.5 meters per second. Next, create another linear rotation and name it around back. Ensure the reference space is global and the moves with body option is not selected. Set the linear rotation parameters. Select Display Vector to check the motion direction is correct. Check that the axis of rotation has the correct coordinates set. Next, you have to create 11 moving polygons. To do that, copy the slat geometry already created and set the copy options with the following parameters. With these settings, each slat will have a start time offset by 0.72 seconds and all kinematics offset by the same time. This creates an even spread of slats along the conveyor. Finally, we have to add conveyor kinematics to both the top and inclined conveyor geometries. Set the following properties for this kinematic. It is good practice to check the display vector to ensure you have the correct movement. In a similar way, add the conveyor translation kinematics for the inclined conveyor top geometry. Set the initial velocity and ensure you have the correct direction for the kinematic. It is good practice to check that the conveyor motion has been applied correctly before creating the particles in the simulation. To do that, go to the EDEM simulator and deselect Auto Time Step. Assign a fixed time step of 0.01 and run the simulation for 10 seconds. Since we have a high time step and no particles created yet, this simulation will run in a few seconds. Return to the EDEM creator, but first remember to set the time back to 0 seconds. Continue with the simulation setup and create the particle factory. Create a polygon geometry and name it to Apple Factory. Change the type to virtual. Set the following dimensions and coordinates. Add a dynamic factory to generate the particles. Set the total number of particles and generation rate. Next, move to the simulator. Ensure your GPU card is compatible to run the simulation. We set the time step to a lower value and change the total simulation time to 15 seconds. To run this simulation, you must use the GPU CUDA solver, which supports polyhedral particle calculations. Once the simulation is finished, move to the EDEM analyst to post-process the results. Here in the analyst, you can configure the display settings. For this example, change the color of the fruit crate. Then, add a rusty steel texture to the sides of the equipment. Finally, import the texture called rubber for the top and bottom parts of the conveyor. Finally, you can color the apples in a dark red color. There are different options for visualization you can explore. Play through the simulation to see how the apples are transported over time. For further information about the EDEM analyst and post-processing your results, check the EDEM e-learning.